Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to physics class today, and in this class we are going to be talking about arrangement of resistors. Before now we have discussed about resistors, and we defined resistors as electric conductors that can oppose the flow of current in a given circuit. And we know that resistance is the ability of a resistor to oppose the flow of current. So our discussion in this class is to look at how resistors can be arranged in a circuit. Resistors can be arranged in two ways in a circuit. The first way is series arrangement. And resistors are said to be arranged in series if they are connected end to end. If one end of a resistor is connected to the other end of another resistor, like that, is referred to as series connection. And in this circuit, we should observe that the current that enters into each of the resistors is the same, but the PD across each resistors is changing. That is, the PD across R1 is V1, the PD across R2 is V2, and the PD across R3 is V3. So it means that if you want to calculate our total potential difference from this circuit, it is going to be V1 plus V2 plus V3. That will give us our total potential difference in that circuit. What I mean by that, it means my V total is going to be V1 plus V2 plus V3 according to the diagram. What we should recall from Ohm's law. From Ohm's law, it has been established that V equals current times resistance. That is, V equals IR. This is coming from Ohm's law. This is what we call ohmic equation. Now, if you bring this into this equation, let me call this equation 2. We bring it into equation 1. What are we going to be getting? We're having this V2, so this is IR, okay? So we're having my V total to be IR total to be equals to V1 will be IR1 plus V2 will be IR2 plus V3 is going to be IR3. Now watch out for something. I have my current to be constant. In this circuit, current is constant. The current that enters into R1 is the current that enters into R2 is the current that enters into R3, meaning that the current is constant. And in this circuit, I have R1, R2, R3. They are not the same. I have V1, V2, V3. They are not the same. It means that the voltage is changing and the resistance is also changing. But what remains constant is the current. So from here, from this equation, I can have IR total equals I into bracket R1 plus R2 plus R3. Okay, this I can cancel this I. I'm going to be having my R total to be equals R1 plus R2 plus R3. So this is the formula that can be used to calculate total resistance of resistors in series. Total resistance of resistors in series. Okay, now let's look at the second case. The second case is the case of parallel connection. Number 2, you have parallel arrangement. Let me use the term arrangement. We have parallel arrangement. And in parallel arrangement, this is when circuits are connected side by side. Series is when they are connected hand to hand. Parallel is when they are connected side by side. Okay, let me have a display of the diagram. Okay, what we have here is parallel connection. And this is a situation whereby resistors are connected side by side. You can see the resistor all are joined here. They have one connection here, and the other side are all joined to a point to give us another connection. And all the resistors are connected to one voltage source. They are connected to one voltage source. So what we can observe in this diagram is that the current varies. The current is changing because at this junction, the current is splitted into 3. We have I1 going to R1, I2 going to R2, I3 going to R3. But what is constant here is the voltage. Voltage is constant, current varies, resistors also vary. Resistors vary. Are we together here? So if I want to get my total current here, and that's going to be I1 plus I2 plus I3. Okay, and also from Ohm's law. From Ohm's law, we have learned that my current is V over R. Current is V over R. Therefore means that I can have my I total, that is V over R total, to be equal to I1 will be V over R1 plus I2 will be V over R2 plus I3 will be V over R3. I'm having V to be constant, that is why it is VVV. But I is changing, I1, I2, I3. R is also changing, R1, R2, R3. Are we together here? And you can see that from here, the voltage can cross out because that is constant. I will now be left with 1 over R total to be 1 over R1 plus 1 over R2 plus 1 over R3. Okay, that is my total resistance. This is my total resistance for resistors in parallel. My R total will be 1 over R1 plus 1 over R2 plus 1 over R3. And for series, total resistance is going to be R1 plus R2 plus R3. We should know the difference. And there's a special case. Under this parallel arrangement, there is a special case of 2 resistors in parallel. If you have 2 resistors in parallel, how do you go about it? That is what I'm going to be discussing in my next slide. For a special case of 2 resistors in parallel, we are going to have 1 over R total to be 1 over R1 plus 1 over R2. We know this. Now, looking for the LCM, LCM is going to be R1 times R2. R1 goes into R1, R2. I'll be having R2 left. R2 times 1, that will give me R2 plus. R2 goes into R1, R2. I'll be having R1 left. R1 times 1, I'll be having R1. Okay, so this means that my 1 over R total is R1 plus R2 over R1, R2. So if I find the inverse of this, the inverse of 1 over R1, 1 over R total will be R total. equals, inverse of this is going to be R1 R2 over R1 plus R2. So this is now going to be equals to product of resistances over sum of resistances. This formula is only used when you have a case of two resistors that are connected in series and in parallel, when you have a case of two resistors that are connected in parallel. Okay, now what we're going to be looking at in the next slide is how we can solve problems with these arrangements, parallel arrangement and series arrangement. This is the first question we are going to be solving. 5 resistors of resistance 0.1 ohms, 1.7 ohms, 2.0 ohms, 1.0 ohms and 0.9 ohms are connected in series. Calculate the value of the combined resistance. This combined resistance is also what we call total resistance, or they can call it equivalent. It can also be called equivalent resistance. They can call it resultant resistance. These are possible names they can give. It can be combined resistance, total resistance, equivalent resistance, or resultant resistance. They all mean the same thing. Okay, so we have been told that this is a series connection. So for a series connection, R total will be 1. For series connection, R total, R combined will be R1 plus R2 plus R3 plus R4 plus R5. I'm having 5 resistors there. So that is now going to be giving me 0.1 plus 1.7 plus 2.0 plus 1.0 plus 0.9. And by the time you put all of these together, the answer should be 5.7. That will be 5.7 ohms. 5.7 ohms. That's the answer to that combined resistance. Example 2. Example 2. We have 4 resistors of resistances: 1 ohm, 5 ohms, 3 ohms, and 4 ohms to be connected in parallel. Calculate the value of the combined resistance. So in this, we have been given the headway that the resistors are connected in parallel. And we should recall that for parallel connection, we have 1 over R total to be 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. And I have that to be 1 over R1 is 1, R2 is 5, R3 is 3, R4 is 4. So from here, I'm going to look for the LCM of 5, 3, and 4, and that should be 60. We're having 60 here. 1 is 60, that is 60. 60 times 1, 60 plus 5 is 60, 12. 12 times 1, 12. 3 in 60, that will give me 20. 20 times 1, 20 plus 4 in 60, and that will be 15. 15 times 1, 15. And then if I put all of this together, I should have 107 over 60. So this is 1 over R total. But this is not the end of my solution. This is not the answer. So I need to find the inverse of 1 over R total. That will give me R total. Inverse of this will be 60 over 107. The answer can be left in fraction. In decimal, 60 divided by 107 is 0.56. That is 0.56 ohms. So this is our answer for our parallel connection of 4 resistors of resistances 1 ohm, 5 ohm, 3 ohm, and 4 ohm. Let's look at more advanced question on this. Question 3 is coming from NECO 2006 question 46. It's an objective question. And we have we have to calculate the effective resistance of the circuit shown above. Don't forget that effective resistance is also referring to the total resistance in the circuit. And we need to also be able to interpret these circuits. This circuit is a combination of series and parallel connections. You can see if the source is from here, this R1, let me label this R1, label this R2, label this R3, and give this one R4. This R1 and R4 are in series to each other. Why? Because they receive the main current from the source. Look at it, when the current is coming from here, it's receiving the main current. That makes it in series. And then when the current gets to this junction, it's splitted into two. Therefore, R2 and R3 are parallel. If R2 and R3 are parallel, then the current will come and combine here again and continue the journey and come as a whole here and enter into R4. That makes R4 in series. So R1, R2 are in series. R1, R4, are in series. R2, R3 are parallel, but their combination is in series to R1 and R4. So if I'm going to find my R effective as was used in the question, effective current is going to be R1 plus R2, R3, they are parallel. R2 in parallel to R3 plus R4. R1 plus R2 parallel to R3 plus R4. Don't forget that R1, R2, R3, if combined, they are in series to R1 and the combination is in series to R1 and R4. So we now go in, we say R1 plus, from the principle of two resistors in parallel, that will be R3 times, R2 times R3 over R2 plus R3 plus R4. Don't forget, special case of two resistors in parallel. So what are the values? R1 is 1 ohm plus R2 is 2 times R3, 2 over 2 plus 2 plus 1. So that is going to be 1 plus 2 times 2, 4, over 2 plus 2, 4 plus 1. And that will be 1 plus 4 in 4, 1 plus 1. That will give me 3 ohms, which is refers also known as 3.0 ohm. And the correct option is C. Correct option is C. So what is it? The interpretation is just to identify which resistors are parallel and which resistors are in series. Okay, let's see if we can apply this knowledge in the next example. Question 4 is coming from Wire Practical Physics of 2016, question 3B, from figure 2. So to calculate the value of R in the circuit diagram above, given the effective resistance as 4 ohm and that the internal resistance of the cell is negligible. So just like we interpreted the last question, you look at this, these two resistors, they are in parallel because they are not receiving the main current. The current splits on getting here. So they are in parallel, but the current comes together and enter here. It means this is in series to the source. These two combination will be in series with this, with 2 ohms. So let me label this. If I want to go by R equivalence, effective resistance is R, the first R, parallel to the second R plus 2 ohms. That is it. Effective resistance is going to be first R parallel to second R, the combination in series plus 2 ohms. So in the question, we've been given effective resistance to be 4 ohms. So I'll have 4 equals, this will be R times R over R plus R. This is a case of 2 resistors in parallel. It's going to be sum of product of resistances over sum of resistances. So that's going to be plus 2. Okay, now I'll have this to be 4 equals R times R, I'll be having R squared over R plus R, I'll be having 2R plus 2 plus 2. R cancel 1 R here, I'll be having 4 equals R over 2 plus 2. Okay, then I look for the LCM. LCM here is 2. I'll multiply everything by 2. That will be 4 times 2 equals R over 2 times 2 plus 2 times 2. So that will give me 8 equals R plus 4. Then R is going to be 8 minus 4, and that will be 4 ohms. It means my R is 4 ohms. Alright, good. And we are moving to the last question of the day. By God's grace, this is going to be the last question of today. Let's calculate the effective resistance between 2 points P and Q in this circuit diagram below. Oh, what we still need to know is that these two are in parallel to each other. The combination is series to this one. So I'll have effective resistance to be 3 plus R2. Let me start with R1, R2, R3. So R1 plus R2 parallel to R3. Okay, so that will be R1 plus R2 times R3 over R2 plus R3. So that's now going to be equals to R1 is 3 plus R2 2 times R3 2 over 2 plus 2. That will be 3 plus 4 over 4, 2 times 2, 4, 2 plus 2, 4, and that will be 3 plus 4 in 4, 1, 3 plus 1, 4.0 ohms. Option B. Option B is the correct answer. So this is where we are going to be drawing the curtain of this class. In this lesson, we have been able to understand the various arrangements of resistors. And we've learned that resistors can be arranged in 2 ways. We have the series arrangement and the parallel arrangement. And that the series arrangement is when resistors are arranged end to end. And to calculate total resistance in series arrangement is going to be R total equals R1 plus R2 plus R3 up to the number of plus up to Rn, the number of resistors we have in the circuit. And also we've learned that we have parallel connection. In parallel connection, we have R equivalent to be 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 and so on, depending on the number of resistors we have in the circuit. And we'll talk about a special case of two resistors in a parallel. So in that case, our R equivalent is going to be product of resistances over sum of resistances, and that will give us that will help us to be able to calculate R equivalent for two resistors that are in parallel connection. And that formula works for just two resistors in parallel. If the resistors involve more than two, that formula will no longer hold. And after that, we were able to apply these ideas in solving problems. I want to believe that with this knowledge, you'll be able to solve problems on resistors connections. If you haven't subscribed to my YouTube channel, please do click on the like button and subscription button for more videos. Thank you for your time. Assalamu alaikum warahmatullahi.